Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about intervals of concavity.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals 5x plus 30, all to the 2/3 power, and we get to find the points of inflection, discontinuities, intervals with the functions concave up and concave down. Now, right here, we have a third root function here. Okay, and that's the only thing that would cause an issue here is taking the third root. But that we can plug in any x value we want and it doesn't cause any jumps or anything like that. So right off the bat, we know what we know about these functions here, essentially the third root, and then we're squaring it. We have no discontinuities exist. So no discontinuities exist here. Now, to find my inflection points and where we're concave up and concave down, we need to find the second derivative and do the second derivative test. So let's go find the first derivative first. F prime of x here, power rule, 2/3 comes down. Keep the inside, 5x plus 30. Subtract the exponent by 1, we have a negative 1/3. Multiply the derivative inside, 5. Simplify this out here, f prime of x. I'm going to keep the exponent as a negative though, but 5 times the 2/3 is a 10/3, and we have a 5x plus 30, all to the negative 1/3 power. Now let's go find the second derivative. So we find f double prime of x here, again 10/3 out front, but we're multiplying that by a negative 1/3 that comes down. Power rule here, keep the inside the same, 5x plus 30. Exponent subtract by 1, okay, and we have a negative 4/3 times the derivative of the inside, which is just 5. Now we can simplify this whole bad boy out here, f double prime of x. 5 times 10 is a 50, but we have a negative 1 up top as well, so we have a negative 50 up top, over, squeaky squeaky here, 3 times a 3 is that 9, so we have 3 times 3, we have a 9 here in the denominator. Then we're bringing this 5x plus 30 down to the denominator, and it's be positive, and so it's going to be the third root of 5x plus 30 all to the 4th power. Okay, we got our derivative there. Alright, so now we have to find where our denominator is equal to 0 and see what happens there, okay, with our second derivative. So I take my second derivative, my 9, and that's the third root here of a 5x plus 30, all to the 4th power, and set it equal to 0. Well, I divide both sides by 9, doesn't really do anything, and I take the 4th root and 3rd power of both sides because it's all going to 0, doesn't do anything. So we really have, the issue happens at 5x plus 30 equals 0. From there, subtract 30, 5x equals a negative 30, and x equals a negative 6. So negative 6 is where we have to do our test. Alright, we do our second derivative test here at negative 6. Okay? And I'm going to pick a value less than negative 6 and greater than negative 6. So I pick negative 10, and f double prime of negative 10, we're plugging into the second derivative right here. Okay? It came out to be a negative 0.016. I just care that it's negative, and we're concave down here. Okay? Now from there, I had to find the value that's greater than negative 6. So I picked f double prime of, I picked 0 here, and it came out to be a negative 0.0596. I just care that it's negative, and again, concave down. So what happens here? We have a concave down that's happening on both sides of negative 6. So we don't actually have an inflection point. So we would say no inflection points exist. Okay. Now, where is it concave up? Well, nowhere. We didn't find anywhere it's concave up, so concave up. No intervals exist. What about concave down, which we have? Now notice how I'm going to write this. Concave down. My marker doesn't die on me here. And we have the interval from negative infinity to negative 6. That's a negative 8, Sean. Negative infinity to a negative 6. And from negative 6 to positive infinity. We just separate that right there. Okay? And now we're done. So our final answer here is no discontinuities exist. No inflection points exist. We're concave up on no intervals exist there, but concave down from the interval from negative infinity to negative 6, and from negative 6 to positive infinity. I hope this video was helpful for you. If it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.